All right, let's take a look at what happens if you end up with a fraction inside the absolute value bars. Once again, I want you to notice a consistency here. You can consider this as the option that you could plug in a positive or a negative to the absolute values. No matter what, you'll have a positive outcome. So we're going to split this up into two once again, keeping this inside exactly as you see it. That's the positive. 4y plus 5 divided by 2 will be less than or equal to 13. Or consider the alternative, you could plug in the negative, and I'll write the quantity as you see it. Negative quantity, because it's all negative. 4y plus 5 divided by 2 is all less than or equal to 13. Now we solve each one individually. You're going to see that your algebra solving process will not change. On the left side, that's the whole quantity divided by 2. You got to undo this division first. Opposite of divide is multiply, so I will multiply both sides of that inequality by 2. 2 divided by 2 is 1. They cancel, which is our goal. You end up with 4y plus 5 less than or equal to, on the right, 13 times 2, 26. Now this is familiar. You can get rid of the constant before the coefficient. The one without the variable goes first. If it's positive, you're going to subtract 5 from both sides. Rewrite it. 5 minus 5 is 0, leaving us with 4y less than or equal to. 26 minus 5 is 21. That says multiply by 4. The opposite of multiply is divide. We'll divide both sides by 4. 4 divided by 4 is 1. 1y. Otherwise just y. Less than or equal to 21 over 4. It's okay if you get a fraction. We started with a fraction. Shouldn't be surprised if we end with one. 4 goes into 21 5 times. That's 20. With 1 remaining. So 5 1/4. Not a big deal. On the right, the other inequality. Definitely in a time like this, I would divide by -1. There's too much going on in there. Opposite of a negative is positive. Parentheses are no longer needed. 4y plus 5 divided by 2. Well, change the inequality. Greater than or equal to -13. That first step with the negative is very important. It changes your arrows, keeps everything straight. Same process as we just did. The whole quantity is divided, so you undo division by multiplying by 2 on the both sides. 2 divided by 2 is 1. It's gone. Parentheses are no longer needed. There's no multiplication there. 4y plus 5 greater than or equal to -26. Earlier we subtracted 5. I'll do the same thing here. Subtract 5 on both sides. On the left, 5 minus 5 is 0. 4y is greater than or equal to. They're both negatives. Same sign, so you add. 26 plus 5 is 31. They are still negative. Opposite of multiply is divide. So divide both sides by 4. Y is greater than or equal to. So your 4 goes into 31 7 times. That's 28. From 28 to 31 is a remainder of 3. So 7 3/4. You can see these are already in standard form. Small values on the left, greater values on the right. Let's take a look at the graph. 5 1/4. Other value is 7 3/4. Close dots for each of them. This says y is smaller than 5 1/4. Smaller than goes to the left. This one says y is greater than 7 3/4. Greater goes to the right. So as you can see, there's a disconnect in the middle. This is indeed a disjunction. So writing this algebraically, would be y is less than or equal to 5 1/4, or the right side, y is greater than or equal to 7 3/4. Cannot be connected. If in doubt, as we just saw, use the graph to help you. Set notation. 2 individual inequalities, 2 pieces of interval notation. This goes out to negative infinity, so I'll start there, to 5 1/4. Close dot, bracket, infinity you cannot plug in, parenthesis. Or, remember the symbol for that? The idea is union, it's a big U, means the same thing as or. I start at 7 3/4, and the arrow goes all the way out to positive infinity. Bracket, because it's closed dot. Bracket, because it's equal sign. Infinity cannot be plugged in as a parenthesis. So now you have your algebraic solution, your graph, your set notations. If I plug in a fraction, you follow the exact same process. It doesn't matter what I plug in here. You'll still separate it with a positive and a negative. At that point, it's just a matter of using your algebra rules.